1 mole of an ideal monatomic gas is heated at constant volume from 300 to 600 Kelvin. Find the heat added to the gas, the work done on the gas, and the change in internal energy of the gas. So we want Q, we want work, W, and delta E thermal is the change in internal energy. Okay, so 1 mole, monatomic. That's going to be important. Constant volume. This is our specific process. The initial temperature is 300 Kelvin. The final temperature is 600 Kelvin. So coming back to our table, constant volume is right here. The work is 0 because the volume's not changing. The heat was that NCV delta T. So coming back, CV, we have monatomic, so we want this top number. So CV is that 3/2 R. So 3/2 NR delta T. We have 1 mole. R is the 8.31 joules per mole Kelvin. Delta T is our final temperature minus our initial temperature. So the heat added to the gas my calculator tells me 3739.5, which of course I don't know anything that accurately. At best, we have the 3 sig figs for the temperature, though that's debatable. It could be essentially 1. Let's go ahead and say that's exact, those temperatures, and we have 3. So you could write it as 3740 joules. I tend to like prefixes or scientific notation, which is why I wrote it with the kilojoule. So we have work is 0, we have Q, the heat now. We want the change in internal energy, which is also delta E thermal. Well, the way we relate work and heat to delta E thermal is through the first law of thermodynamics. Delta E thermal has to be Q plus W. That's 0. So delta E thermal ends up being the same as the heat because there is no work done.